All right, so this is just a good way to view my Python programming. This is what we're going to be looking at. Okay, so right here we have temperature genes. So that's the title of this notebook that I made. Below is a function for comparing gene sequences from a tab-separated file or a TSV with 3 tabbed identification information, and the 4th tab as a gene sequence. N stands for the number of sequences as the threshold for matching. So what that basically means is that I have a file that is a list of, basically you're going to have a list of something, 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 and then the 4th item in that list is going to be the actual sequence of the gene. And so you have 3 identifier information like the name, alternate name, and then the position on the chromosome or gene or whatever. So you have 3 different elements in that list, and then you have the last 4th element of that list is going to be the sequence, and it does that over and over again. So it has a pattern of identifying information, identifying information, identifying information, then gene sequence, and then identifying information, identifying information, identifying information, and then gene sequence. So it does that over and over again for, I think it's like 200 genes. So it's a really big list with a bunch of stuff in it. And so my goal is to read that into here and then to separate it into one list of just identifying information and another the different list of the gene sequences, and they're corresponding, so I can put them together and I can match them up and remember which gene had which sequence. So that's a first task that I do here, and that's a file name. N is the number of base pairs I plan to compare, which isn't important for this top part, but it's going to be important when I start doing my analysis later on. That's what I talked briefly about. The import function is where you want to import a module or a package that's pre-installed in Python. So there's some very popular ones like NumPy, SciPy, there's scikit-learn, which is a machine learning or artificial intelligence kind of package. I've worked with all 3. This is CSV, another pretty popular one. It's for comma-separated files, basically, and it lets you, gives you some tools, like new functions that you don't have in Python, but so these are developed by other programmers. They've developed these tools. A lot of people want to use them. So then Python, takes that whole package, makes it a module that you can call upon. So anyone, who runs Python can import this package, and then you have all these new functions that you can work with. So in this case, we have this new function with open file name as file, and we have the csv.reader. That's a new function. And you don't really have to understand this part of it. That's just a kind of a structure for opening a file and then reading the file line by line. And here's where we get the empty list. So this is kind of similar to what you guys did, where you have an empty list and then you start appending to that list, right? So you have an empty list and then you go through a for loop, which is right here, and you append to that list. So can anyone explain what this does? Just this section. I can zoom in a bit. So. How about I'll break it into more basic things. So what does this first line do? We'll just start from down there and then go across. So what is it gonna? So what is this? Well, what is this list specifically? List of genes. Yeah, that's what I talked about. That pattern of 1, 2, 3, and the 4th one's going to be the sequence. That's a big list right there. What is this? Mm-hmm. So in this case, this gene list is it's a little bit. Okay, so wait, let's see. Position equals 4. Okay, so yeah, so I go through. This is kind of a misnomer. I probably should call this item or gene information or something, because a gene has 4 elements, and I'm treating each element as a gene, which is probably not correct or whatever. So this might be misleading, but basically, this right here is the position is equal to 4. That's something I added, but then so don't really pay attention to that. pay attention more to this part right here. So can anyone tell me, just don't even pay attention to this portion up here, that's just kind of a thing I had to do for my own data set, but after for this for loop, what did I do to each of these genes in the gene list? If you have any questions about that, feel free to ask me. That'll help your understanding. So, so
you're like separating it for each entry into a list. You're adding a bunch of data onto the end of it. You're adding the gene info. You're adding the sequence. All of the sequences going to go in a separate list.
Yeah. So I'm going to have a sequence list, and then the 3 identifying information is going to be a different list. So what you see here is that I'm going to, first, it's going to be the first item in the gene. So each of these right here are actually a list within this list. So this is a big list of lists, if that makes sense. So each list within this list is 4 items long with the 3 identifying informations and then a gene sequence. So in this case, I'm looking at the first item in this gene, basically, which would be the first identifying information. And I'm going to stream that and then basically append that to the name list right here. So the first, I'm scrapping the middle 2 identifying pieces of information, if that makes sense. So there might be 3 different pieces of identifying information. I just say, the first one's the most important one, that's the name. From that, I can get the other pieces. So I'm just going to take the first one and append it to the name list. So it's going to have a list of all the names of the gene. Then I say, well, I'm going to set sequence equals gene position. And what that means is that the position is equal to 4, right? So that's a 4th item in the list. So you can treat this as 4, kind of like this is the first item in the gene list. This would be the 4th item in the gene list, and I'm going to set that equal to the sequence. And in that case, in most of these genes, that would be the sequence. But in some of them, there was some weird stuff, which is why I said, the length is actually less than 50, then, position is equal to 5, because some of them have like 4 identifying informations, and the 5th one's going to be a sequence, which is kind of different. So I try to work on that a bit. That's what this was for. But basically, you're going to separate the 2, the name and the sequence apart, and then you're going to append them in the same order. So the first gene name will be here, and then the first sequence will be here. Then the second gene name, then the second sequence, third name, third sequence, and so on and so on. If that makes sense. That's a little more confusing, but let's see. Here I just do some parameter setting. That's basically to set up, let's see, this is a better one, I think. Quite long. Okay, so this is 30. Okay, I'm gonna. Here, let's see. I'll just walk through here. Okay, so for sequence and sequences list. What about this? What about this part right here? It should be simple enough. I'm gonna zoom in a bit. Does anyone kind of get this section? So. Yeah. So I have a new list, that empty brackets again. These are very powerful tools for programming. You set a list name equal to an empty bracket list. And then I'm doing a for loop. So for sequence and sequence list, remember that's a list of sequences we made up here, which you're going to find the length of that sequence, right here. So how long it is, how many items are inside that sequence. So if it's a really long sequence, then it's going to have, hundreds of different base pairs inside. So depending on what number that is, I'm going to append that to length of list up here. And I just do that for each one of those. And what I'm trying to figure out here is what's my biggest gene? Which gene has the most nucleotides? Which gene has the most elements inside? And based off of that, I need to set up my next function to be around that value. And if you see here, I said max length is equal to the max, which is the biggest number inside of this list. So that's where I find the biggest gene. I'm going to find how many elements inside that biggest gene. And then that's useful here, where I said y is equals to n minus 1. So remember n, which I said way back up here, was the number of genes I want to compare. So if I want to have a big sequence, that has A to C, T, or G, in different combinations for 100 different letters. If I wanted to find anywhere within those two different 100 stretches, and I want to find 6 parts that match. So if it goes A, C, T, G, C, the other part says A, C, T, G, C. You want those parts to match, and it has anywhere along those 100 stretches. And that's basically what I'm trying to find here. So if it's 6, then you're gonna find max length minus y, which is your max, minus your whatever it is, and that's how many times you're gonna iterate through this basically. So for sequences list. If y is greater than length of sequence, you can continue, which moves on. Else if, can anyone tell me what this does? This part.
You set the variable order equal to the sequence list, and that lets your indexing the sequences.
Yeah, so indexing is another function kind of like append, right? Where you have, it's weird, you have a list and then you dot and then you have your function. Index in this case, which we haven't learned yet, is where you find the position of that sequence. So basically, I'm iterating through here, right? Sequence and sequence list. When I index it, so if this is like the third sequence in the sequences list, it's going to give me 3. So order will be equal to 3, right? And then sequence dictionary. That's a Python dictionary. We didn't cover that. Probably should cover dictionary sometimes. But okay, dictionary has those weird squiggly brackets. So that's an empty dictionary. And a dictionary, you can imagine it as a very clever way of organizing a big set of numbers that go several layers deep. So kind of if you had a real dictionary in real life, right? You would have your dictionary name. It could be Webster or whatever volume it is. That's how you'd identify which dictionary you're using. And inside of it, you're going to have letters, right? You can have go A through Z, and that's how you search through the dictionary. And then within each letter, you're going to have all the words that begin with that letter. The same thing follows in a Python dictionary where you have a dictionary name, and then inside of that, you're going to have a bunch of things called dictionary keys. And those keys are basically a list themselves. So when you go inside that key, you're going to have another list inside that key, which has a bunch of different stuff. So in this case, my sequence dictionary will be right here. I established a few keys, which are the gene sequences. And then inside the gene sequences, which are just really long stretches of whatever n long pieces, you're going to have the list of genes that have that stretch of n things that match with it 100%. So you're going to have basically, it's a way of organizing stuff so kind of like directories in Unix or Linux. You have a big directory, a bunch of smaller directories within, and inside of each of those directories you have the actual values inside for each. So it's a great way of organizing stuff and for analyzing stuff. So this is what I have. Basically what this does, let's see. What this will do is go through and basically append these sequences if it matches. So that's what this is basically right here. It establishes a key in the dictionary for that sequence if that key does not exist already. So that's what this part does. And if that key does exist and we do find this part that matches in the sequence, then we're going to append that sequence name, which is the name list, remember, in the same order, to this sequence key. So that way you're going to have some kind of organization of different sequences. Else, we do all this other stuff, and this is probably more complicated than I thought it was going to be. But basically, if you get the idea of appending, main thing I want you guys to get away from this is that kind of the smaller tools that you're kind of used to, like the empty brackets, empty list, append functions, if statements, for loops are kind of the main building blocks for every type of Python function. So even complicated ones, complex ones, really big ones, they're still being made up of primarily these main building blocks that you guys have. So, and then just a good way to visualize what I actually do. So I call upon my function just like how you guys do. You have your parentheses. In this case, I have two parameters. One is a string of the file name, and the other parameter is how many base pairs I want to actually look at. So here we have, this is the first key in the dictionary. So this is your opening dictionary. This is a key in the dictionary itself, which is what I told you about how you organize. And inside of that key, we have all of these genes. So all of these genes right here have a sequence that has this inside of it. So that goes on for quite a bit, right? And if I could see. All right, so this might be a bit smaller. Okay, so I mean here you see this is a longer one. So if I set the parameters to a different one, if I set the parameters to 21 instead of 7 up there, so you can look at the 20 sequences or base pairs that match, and then it's going to print out the genes. So all the genes have this matching are these three: the YCR096C all the way to YCR021C. These are the genes that have this sequence inside of them, and so on and so on. So that's basically how most of it functions. So it might be a little complicated, but hopefully it gives you a good idea of kind of how advanced you can get in Python with kind of basic building